Good morning, everyone. This is Bureau of Indian Standard Design Example for M20 grade. Myself, Dr. J. Sayaruban, Department of Civil Engineering, Rogani College of Engineering and Technology. Data required for a mixed calculation of M20 grade. The compressed strength 20 Newton per mm square. Cement type is artery port on 50 grade cement. Maximum size of the aggregate is 20 mm. Workability required at the construction site is 100 mm. This is slump value. The exposure condition is taken as moderate. Concrete placing method is pumpable concrete. Cc gravity of the cement is 3.15. Cc gravity of the coarse aggregate is 2.8. Cc gravity of the fine aggregate is 2.7. Fine aggregate CU size is unforming zone 2 table IS 38. So step number 1, calculation of target mean strength. Normally the target mean strength is calculated that compressed strength at 28 days. So FCK dash is equal to FCK plus K into S. K is a statistical value usually taken as 0.65. S is the standard deviation for the each grade of concrete. This is taken from table number 1 of IS 10262 2009. From the table, the standard deviation value for M20 grade for concrete mix is 4. From we have to calculate the target strength, that will be is equal to 20 plus 1.65 into 4. I'll get the value of 26.6 Newton per mm square. Next, step number 2, the selection of water cement ratio. The water cement ratio is taken from the table number 5 of IS 456 2000 for a exposure condition. For the moderate condition related to the plain concrete, the value of water cement ratio is 0.6. Based on the number of trials using concrete mix, adapt the water cement ratio of 0.55. Step number 3 is the selection of water content. The value of water content is selected from the table number 2 of IS 10262 code book. The maximum size of the aggregate is 20 mm for a water content of 186 liters. The water content is applicable for 25 to 50 mm slump value. For every increase of 25 mm slump, the value of water content is need to increase by 3%. Hence, in this case, the slump value is 100 mm. The value is increased by, for every 25 mm, we have to increase the value. So, we will get an increase by 6%. So, final water content will be is equal to 186 plus 6 by 100 into 186. So, we'll get a value of 197.1. Then step number 4 is a calculation of cement content. For the available value of water cement ratio, we have to determine the cement content. So we defined the water content, water cement ratio is 0.55. From the water content value is 197.16 liters. It is the cement value we have to find out by total water content divided by water cement ratio. So that will be is equal to 358.47 kg per meter. So the maximum content is 450 kg per meter cube. So hence this is. Next we have to determine the coarse aggregate and fine aggregate proportion. The volume of coarse aggregate per unit volume of total aggregate value are initially considered from the table 3 of IS 10262 code related to the different fine aggregate zone condition. The volume of coarse aggregate per total aggregate is 0.62. Correction in coarse aggregate value specified in the table water cement ratio is 0.5. So for every plus 0.05, the change in water cement ratio is minus 0.01. For every minus 0.05, change in water cement ratio is plus 0.01. So final volume of the coarse aggregate becomes 0.62 minus 0.01. That will be is equal to 0.61. Now the volume of fine aggregate is equal to you have to take it as a 1 as the total volume minus 0.61, that will be equal to 0.39. There is a fine aggregate volume. Step number 6 is the estimation of concrete mix calculation. So assume volume of total concrete is equal to 1 meter cube. So the volume of cement is equal to mass of the cement by specific gravity of the cement into 1 by 1000. So already we determined the mass of the cement as 358.47. Specific gravity of cement is given in the assumption that is given codal provision 3.15 into 1 by 1000. So that will be equal to 0.1138 meter. Next we have to determine the volume of the water equal to mass of water divided by specific gravity of water into 1 by 1000. So 197.16 divided by specific gravity of water is 1 into 1 by 1000. That will be equal to 0.19716. So the total volume will be equal to 1 minus this B minus C. So 1 minus 0.1138 minus 0.1971. So that will be equal to 0.68904. Next, we have to determine the mass of the concrete. So mass of the concrete is equal to the D value into volume of coarse aggregate into specific gravity of coarse aggregate into 1000. So substitute all the value. We will get a value of 1176.88 kg per meter cube. So mass of the fine aggregate is equal to D value into volume of fine aggregate into specific gravity of fine aggregate into 1000. So 0.68904 into 0.3961 into 2.7 into 1000. So you'll get a value of 736.90 kg. Calculation of mixed proportion for the final tray. So cement we have to get the value 358.47 kg per meter cube. Fine aggregate 736.90 kg per meter cube. Coarse aggregate 1176.88 kg per meter cube. Water is 197.16 kg per meter cube. For a final mix of M20 grade concrete as per 1026 code, cement is to fine aggregate is to coarse aggregate at a water cement ratio. So we have to get the value. This entire value will be divided into water with a cement ratio. So we'll finally get a value 1 is to 2.05 is to 3.283 is to 0.55. This is the actual mix proportion of a given. This is all about the Bureau of Indian Standard Mixed Design example. Thank you so much.